First of all, it should be noted that in a pure semiconductor, there are equal numbers of electrons, which are negatively charged particles, and holes, which possess a net positive charge. The most basic semiconductors are silicon or germanium, both of which are tetravalent, that is, they have 4 valence electrons on the outermost shell. Because 8 electrons is a stable number, one more or one less electron will change the charge of the atom. In a tetrahedral arrangement, each electron forms covalent bonds with 4 surrounding atoms. Let's simplify the model to make it easier to understand. At absolute zero, the electron is strongly bonded to its parent nucleus. However, if heat is applied, the thermal energy may become greater than the energy binding the electron to the nucleus. This means that the heat will break the covalent bond. The bond is broken, sending the electron from the valence band into the conduction band, leaving in its place a positive charge, or a hole. Since the atom now has a net positive charge, an electron in the neighbouring atom may be attracted to it, so that the hole seems to have moved to the neighbouring atom. The electron-hole movement throughout a semiconductor is random. However, if an electrical field is applied, the electrons are urged to fill the holes so that the holes move in the direction of the current, whilst the electrons move in the opposite direction, filling in the holes. This concludes my dynamic presentation. Hope you enjoyed the show.
Let us know about the valence band, conduction band and forbidden energy gap. The electrons in inner shells are strongly bound to the nucleus. A band which is occupied by the valence electrons or a band having highest energy is defined as a valence band. The valence band may be partially or completely filled. This band can never be empty. In some materials, the valence electrons are loosely attached to the nucleus. Even at room temperature, some of the valence electrons can leave the valence band. These are called as free electrons. They are responsible for conduction of current in a conductor and are henceforth called as conduction electrons. The band occupied by these electrons is called a conduction band. This band may be an empty band or partially filled band. The separation between valence band and conduction band is known as forbidden energy gap. If an electron is to be transferred from valence band to conduction band, external energy is required, which is equal to the forbidden energy gap.